So we are doing special integrals too, that is three different integrals which are not directly standard integrals, but obviously they are derived from some standard integrals and eventually we can use them as formulas. So the first one being integration under root x square plus a square dx. Second one being integration x square minus a square dx. Third one being integration dx. Fine. Now I'm not getting the full. Yeah, fine. So now let us prove one and then we are going to write formulas for the next two. So let us start off with the first one. So let me consider I. I is the integration under root x square plus a square dx. So this, considering this one as your first function and this as your second function, we have under root x square plus a square into integration dx minus integration derivative of this. So derivative of this is 1 by 2 root over of x square plus a square, but x square is there, so 2x here, and integration of dx will be x, so whole dx. This 2 gets cancelled, so therefore we have x root over of x square plus a square minus integration of x square by under root x square plus a square dx. Right? Now in the next step we can write x under root x square plus a square minus, now I am doing a little bit of manipulation. What is the manipulation? I am adding one a square and I am subtracting one a square, and this is under root x square plus a square. See, I think I can write this. Now after this, x root over of x square plus a square minus, if you just break it, taking this as 1 and taking the other as 1, so this will give you under root x square plus a square dx, and this minus becomes plus integration a square by under root x square plus a square dx. Right? Now this thing is completely your I, that is what you have started with here. So therefore what I can do, I can take this on the other side and make it 2i. So therefore 2i is equals to x root over of x square plus a square plus these a square comes out. So if these a square comes out, this will be a square integration dx by under root x square plus a square. Right? So therefore this becomes x under root x square plus a square plus a square. Now dx by root over of x square plus a square, if you remember, this becomes log of mod of x plus root over of x square plus a square plus c. Obviously I will be writing that c. Now this is your 2i, So what will be your I? I will become x by 2 root over of x square plus a square plus a square by 2 log of mod of x plus x square plus a square plus c. So this is what it becomes. So this is basically your formula which you will be using in the problem, right? Now let me write the formula for rest of the problem, rest of the other integrals. So therefore the first one, let me rewrite the formula once again. So the first one, that is integration dx by under root x square plus a square, or let me use a different color, that will be better. So integration, I hope it is visible, dx by under root x square plus a square, that is your x by 2 under root x square plus a square plus a square by 2 log of mod of x plus root over of x square plus a square plus c. This was the first formula. Similarly, if I go to the next one, that is the second one, the second one will be integration dx by, I am sorry, what am I writing? It is under root x square plus a square dx, sorry. So this is the next one, under root x square minus a square dx. So that is x by 2 under root x square minus a square minus, so remember this, when it is plus, here it will be plus, when this is minus, here there will be a minus, a square by 2 log of mod of x plus under root x square minus a square plus c. And the last one, integration a square minus x square dx, that is equals to x by 2 under root a square minus x square, so that part is same, plus a square by 2 sine inverse x by a plus c. Fine. So these are the three formulas which we are going to make use of to solve the problems in this topic or this part of the topic. So let us take few problems and let us solve. So let me just clear up the board. Now let us take few problems. The first problem being integration 4 minus under root 4 minus x 4 minus x square. So this is example 1, that is integration under root 4 minus x square dx. So let us take this. Now obviously this falls in which category? This falls in this category, 4 minus x square. This is in this category, the third one. Now obviously this one is a very simple problem. Just looking at it, I can say that this is under root 2 square minus x square dx. And so just going by the formula, this will become x by 2, 2 square minus 4 square, that is 4 minus x square, plus a square by 2. So a square here it is 4, so therefore 4 by 2, sine inverse x by a, so this is sine inverse x by a plus c. Or if you just rewrite it, x by 2, 4 minus x square plus 2 sine inverse plus c. This is the problem. Now let us take another one. Say integration under root 4x square minus 9 dx. Now here, to solve this problem, always remember that whenever you have such problem, the first thing is you have to always ensure the variable part is without any coefficient. So variable has to be left alone. So in that case, what to do? I can do one thing, divide the whole thing by 4. So if I divide the whole thing by 4, 1 by 2 will come out. Integration under root x square minus 9 by 4 dx. Fine. So now this is in the form x square minus a square, a being 3 by 2. So therefore half, this whole thing is common, x root over of this, x root over of x square minus 9 by 4, or sorry, this should be 2, not 4, this is 2, x root over of x square minus 9 by 4 minus a square by 2. Now a square is 9 by 4 itself, so by 2, that is 9 by 8, so 9 by 8 into log of mod of x plus root over of x square minus 9 by 4 plus c. Now obviously this part is inside bracket. So now let us just remove the bracket. So 2 goes inside, x root over of this becomes 4x square minus 9. You can see why, because if you take LCM, then this will become 4x square minus 9 by 4. This 2 and inside 4 will get cancelled. Minus this becomes 9 by 4 log of mod of x plus root over of, now not x, if you see this 4 comes up here, so this will be 4x square and the whole thing will be divided by 4, and there will be by 4 which is inside, so it will come out as by 2. So if you take LCM once again, so this will be 2x, and log 2 will be outside, so that will be going into your constant part, so let that be under root 4x square minus 9 plus, right, if you just take the LCM. So therefore this is your final answer. Clear? Right? Let us take the third example. Now the third example will be a example where it is not directly given in the form, it will be reducible to that form. So Now let me just find out where the problem is. Yes, got it. So this is integration sine x cos x root over of sine to the power 4x plus 4 dx. This is the problem. Now before we can start, we can see that this is not given in the exact form that which we know, or not given in any of this form. So definitely we have to convert this first into a workable form, and then we can go on integrating. So what to do? See here, let sine square x is equals to some t. Let me take it as t. Now if I am taking sine square x as t, then definitely 2 sine x cos x dx becomes dt, or if I take this 2 on the other side, this becomes dt by 2. So therefore I can just reframe the whole integration as integration sine square x whole square, so this will become t square plus 4 into dt by 2, so half will be outside. So this is your actually integration, means it is reduced down to this form. Now the rest of the integration is simple, so let us keep half outside and then let us do the rest of the integration. So this will be t by 2 integration t square by 4 plus 4 plus a square by 2, so 4 by 2, that is 2. I am not writing 4 by 2 separately, I am just writing 2 log of mod of t plus under root t square plus 4 plus c. Right? Now obviously t was a variable which I have made use of. T is not there in the problem, so therefore I will be just changing it. Now let us take this 2 also inside, so this becomes t by 4, so this will become sine square x by 4 into sine to the power 4x plus 4 plus half and 2 gets cancelled, log of mod of sine square x plus under root sine to the power 4x plus 4 plus c. Now here I think I need not put here any mod anyway, because sine to the power 4x plus 4 is also positive, sine square x is also positive, but still keeping a mod is fine. Always it is better to keep a mod. So this is your final answer. Right? Now let us take few more problems. Okay. Example 4. So let me take example 4 here. Let us take this one. Integration x square plus 8x plus 4 dx. Now you can see this is not directly in the form, but I have to reduce it down to integrable form, and then I have to do the integration. So basically what to do, I have to do a whole square thing. So whole square thing, I can do it something like this: x square plus 8x plus 4, so 2 into 4 2 into 4 into x, so plus 16 minus 16, so x square plus 8x plus 16 minus 16 plus 4. So this is how it comes, dx. So therefore this becomes under root x plus 4 whole square minus 12 dx, right? Now you can just solve it right from here itself if you don't have any problem, or if you are facing difficulty by keeping it, you can always take a substitution and then you can solve it. So for easy understanding, let me take a substitution just in order to make you understand how it works. So let x plus 4 is equals to some z. Now obviously this will give you dx equals to dz. So nothing changes much. So therefore your integration will become integration under root z square minus 12 dz. Right? So this is in the form under root x square minus a square. So therefore this will be z by 2 under root z square minus 12 minus a square by 2. Now a square is 12, so 12 by 2 is 6 log of mod of z plus under root z square minus 12 plus c. This is what you get. Now let us replace everything back. So x plus 4 by 2 under root. Now what was z square by 12? Z square by 12 was this original thing. So therefore x square plus 8x plus 4 minus 6 log of, what is z plus 4? This is x plus 4 plus z square minus 12 was the original thing, that is x square plus 8x plus 4 plus c. Right? So this is your problem. This is basically your problem. Now the last question is a little bit not difficult, I should say. You have to bring it in the integrable form, you need to do a little bit of work. So let me just write it down if you have understood this. The last one, that is integration x plus 3 under root 3 minus 4x minus x square. 3 minus 4x minus x square. Now till the previous problem there was nothing outside, but from this problem onwards there is something outside. So we have to deal with this something outside. So before we deal with this something outside, let us see, we have to, this is in the form, so this integration is actually in the form px plus q into integration of ax square plus bx plus c. Now here this px plus q has to be written in the form some lambda times derivative of this, that is lambda times ddx of ax square plus bx plus c plus some constant mu. I have to write it in this form. Now to write this, what to do? See here, what is the derivative of this whole thing inside? So this is your minus 4 minus 2x. So minus 4 minus 2x. So I have to multiply by a 2 and I have to divide, I have to multiply by a minus half and then I have to multiply by a minus 2. So this x plus 3, this can be written as minus half into minus 2x minus 6. Just check for yourself. if I multiply by a minus half, then this is what you get. Then I can write this as minus half minus 2x minus 4, which is basically the derivative of this, and minus 2 is there if I take it outside, so therefore it becomes minus half minus this, so this becomes plus 1. Right? So this becomes your lambda and this becomes your mu. Now let us reframe the whole thing. So this will be so therefore I can write this as minus half outside. I can write this thing as minus 2x minus 4 into root over of 3 minus 4x minus x square dx. Then plus 1 or plus integration 3 minus 4x minus x square dx. See, I can write this. Now mark this whole thing as your I1, that is first part of the integration. Mark this whole thing as I2, second part of the integration. We will be doing it separately. Now first part of the integration is simple. It is very easy to solve. What to do? In the first part, I1, see, if I take this as z squared, then this whole thing becomes dz, right? So therefore this becomes minus half integration, this is z into this whole thing becomes 2z dz, considering this part as your z, z square, right? So therefore this 2 gets cancelled, you are left with z square dz, so you are left with z cube by 3 with a negative sign. So z cube by 3 is basically minus 3 minus 4x minus x square whole to the power 3 by 2 by 3 plus, this is the first part, this is the first part. Then in the second part will be normal integration we just did in the previous problem. So in the second part, it is, first I have to make it in the whole square form. So if I try to write it in the whole square form, 3 minus 4x minus x square, so this will be, I have to add a 4 and I have to subtract a 4. So this will be 3 minus 4, 3 plus 4 minus 4x minus x square dx, or this is 3 plus 4 is 7 minus x plus 2 whole square dx. So this is in the form a square minus x square under root a square minus x square. So therefore this will become, now taking this as z or something, I am not doing it because I have to write 2-3 steps extra, so I am doing it directly. If you find any problem, please ensure you consider this as something and then take the substitution and do it. So therefore this will be x by 2, but remember, not x by 2, this will be this whole thing divided by 2. So therefore x plus 2 by 2 under root this whole thing, that is what we started with, that is 3 minus 4x minus x square, plus a square by 2. Now this is a square, so this is 7 by 2, sine inverse x by a, so this by this, so this is x plus 2 by root 7 plus c. Put a bracket. Yeah. Right. So therefore your final answer will be, so therefore your final answer, that is integration, if I am calling it as I, that is equals to I1 plus I2, that is minus 3 minus 4x minus x squared whole to the power 3 by 2 by 3 plus x plus 2 by 2 under root 3 minus 4x minus x squared plus 7 by 2 sine inverse x plus 2 by root 7 plus c. So a very room full of solution that you can see. It's a huge solution, as you can see, but the one thing is, if you do it separately taking I1 and I2, then it is definitely not a problem. These are very good problems for 6 marks. This is a very good problem for 6 marks. If you are just solving this, be careful and ensure you do it, with some in cool mind, obviously. So that's it. That is our class. We are left with only one part, that is our properties of definite integral, and once we are done with that, then the chapter is over. Fine. So I will see what next chapter to do. Thank you.